Okay, students. So now here I have a model of a home electric circuit that I'm using in the lab to explain to you all the components of a home electric circuit. Now you all know we get power supply from the national grid. The service provider is the National Electricity Board. So from their national grid, main power is supplied to sub-centers, because there the power comes in very high voltages, about 220 kilovolts, and then it undergoes step down transformation where the voltage is reduced, and in the substations also, sub-centers where distribution takes place, there also the voltage is reduced, and before power is supplied to the household, that is our household, it is brought down to 230 volts. And usually the current that is supplied to us is alternate current. And when we say alternate current, it has a frequency 50 Hertz frequency. So 230 volts, 50 Hertz frequency current is distributed from the national grid to each household. And that current comes through the distribution wire. From the main wire, it comes to the distribution wire. From the distribution wire to each household, electricity is provided by the supply wire. Normally, you all know in your households, the supply wires are somewhat broad, the diameter is high, and also they are black in color. Now here, if you look at this circuit, this is a white color wire because I'm getting the current. Now this is inside the lab, we have a model only. So this is actually connected to one of the plug sockets. So that is why this wire is white color. But in your household, normally the wire that comes in will be black in color. Then you all know, students, when power is supplied, electricity is supplied to devices, the household circuits, there are 3 wires used in the circuit. And these 3 wires have 3 different colors. If you look at this wire, this is a brown color wire and that is a live wire. Normally, electricity flows into the circuit through the live wire. Then we have this blue color wire. That is the neutral wire. After flowing into the device or to the circuit, electricity flows back through the neutral wire. Then there is this green color wire. That is the earth wire. Now, like we said, 230 volts of current, 50 Hertz, and also the amount of current that is supplied to the household is 40 amperes, a maximum current of 40 amperes. If there is more current, if there is a current supply greater than 40 amperes, then of course it can damage the devices. So that has to be prevented. So all these current is supplied by these 3 wires, or there are 3 wires involved in the circuit, and these are the components. We will look at them one by one. So this first component, that is known as the overload circuit breaker or the service fuse. Now if you look at the service fuse, it is in the on position now. When you push this lever up, it is on. When you bring the lever down, it's going to be off. This is the off state. And this particular overload circuit breaker belongs to the service provider, that is the electricity board. This and the second component, that is the electricity meter, both those are components of the service provider, that is the electricity board. So if there are any problems in these 2 devices, these 2 components, the consumer, that is the people living in the household, should not meddle with it. It has to be reported to the service provider, the electricity board. They will look into the problem. So the first component, overload circuit breaker. Now here you can see the live wire is connected to the overload circuit breaker. Only the live wire is connected there. Then you can see from the overload circuit breaker or the service fuse, a live wire connection is given to the electricity meter. And here you can see there is an indicator and the units are red here. And here you can see kilowatt hour meter, because the units are measured in kilowatt hours. So like I said, both these components, overload circuit breaker and the electricity meter, both of them belong to the service provider. Thereafter, all the components belong to the consumer. Now here you can see the meter, electricity meter, it has both connections, the live wire and the neutral wire. From the electricity meter or the electric meter, there is a connection given to the consumer unit. Now in the olden days, we had after that there was the trip switch, the isolator and then the distribution box. But the modern households have all those things together. The isolator, the trip switch and the distribution box. Everything together is known as the consumer unit. We have a consumer unit here. If I open the lid, here what you see is the isolator. That is the main switch with the main fuse. So here I said 40 amperes of current. If there is current more than 40 amperes, the overload circuit breaker gets switched off and the power supply to the household is cut off. But here, that is the isolator or the main switch with the main fuse. If there is a current flow more than 30 amperes, this will get turned off. Now here also you can see that the lever is turned upwards, that is in the on position. If we bring the lever down, that is the off position. So you can turn it on and off manually also. So by turning off the isolator, we can cut the power supply to the household circuit. Then the next component here is the trip switch. The trip switch or the RCCB, that is the residual current circuit breaker. When there is a power leakage, now you have the electric appliances, there is the earth wire connected to the casing of the electric appliance. If there is a power leakage, then automatically the trip switch or the RCCB will get switched off. That is this component. Then after that, we have the distribution box that distributes current to different parts of the household. And that particular distribution box consists of MCBs, miniature circuit breakers. Because there are mini circuits and you all have to remember, students, all the electric devices, that is the bulbs or the plugs where we connect the electric devices, they are all connected in a parallel manner. Now, all these components are connected to these miniature circuit breakers and the household is divided into different parts. Now, here you can see there are two MCBs. That means the main line divided into two components. So, if there is a problem in one of the parts of the house, one MCB will turn off. There will be no power supply to that part of the house, whereas the other part of the house will have electricity. That is the function of miniature circuit breakers. So this whole thing is the consumer box. Then from there you can see, like I said, there is parallel connection. All the switches, plugs, everything is connected in a parallel manner. Here you can see switches. Now in this there are two switches. There can be just one switch, 2, 3, 4, depends on your requirement. You can have different types of switches. And here this is the plug socket. So switch is connected to the light circuit where we connect all the bulbs. Here you can see a CFL bulb is connected and here you can see a fluorescent bulb is connected. Now all these are connected to the light circuit. Whereas this one is the plug circuit. Usually the light circuit, the current that flows through the light circuit is 6 amperes. Whereas through the plug circuit, there is a current flow of 13 amperes because for the electric devices, we need more current. So that is the plug socket. And these are the components of the domestic or household electric circuit. In the next video, I will show you all each of these components and how they function. Okay students, so like I said, now we will look at the different components one by one. As you all know, from the national power grid, we get power supply to the household through the distribution wire and then the service wires. Then power supply is first given to this overload circuit breaker or the service fuse. And as you can remember, only the live wire is connected to it and 40 amperes of current will flow through it. And here you can see the lever when it is down. Now this is different from these switches. Normally here you can see this is in the off position. When you press it down, it means the on position. But these are all different. Here you can see when the lever is down, it is the off position. You have to remember that. When the lever is down, it is the off position. When we put the lever up, it is the on position. So normally, when there needs to be electricity supply to the household, the lever has to be up. So from the main connection, we will be receiving electricity to the household. If there is a current greater than 40 amperes, automatically this switch will get turned off so that the household will not be affected by excess current. So that is why we call it the service fuse. Now I have here with me a fuse that was used in the old days. Here you can see this is a ceramic casing. Now ceramic does not conduct electricity. You can remove this like this. This part is the fuse. So here you can see, students, there is a wire there. That is part of the fuse. That is made up of an alloy that is made from tin and lead. Now when there is current supply to different electric equipments, only part of the current is consumed by the device, whereas some of the current will become heat. But when there is excess current, like I said, more than 40 amperes current, there will be a large amount of heat produced. Due to that heat, this particular wire will melt. Now, when that wire melts, there will be no current flow because the circuit will be incomplete. When the wire melts and the circuit gets disconnected, there will be no current flow to the household circuit. So that helps to protect the household devices from high current. So what we can do is, in the early days, you can replace this wire and then you can plug it back and use it again. That is the overload circuit breaker or the service fuse. Now, if you want to turn it off manually also, you can do that. Even the electricity board, if they want to disconnect the electric supply to a certain household, they can do that using the overload circuit breaker because this component belongs to the service provider, that is the electricity board. So you all have to understand the function of an overload circuit breaker, students. Okay, students. So now we are looking at the different components of the domestic electric circuit. First I explained to you all the overload circuit breaker. Now you all know at this position when the lever is down, there is no power supply. Now even if I switch this on, there will be no power supply, so the bulb does not light. Then if I turn this on, now as you can see, now the power comes on. I can switch on one device, off it, turn on another device, off it, all when there is power supply. And here you all know the live wire is given to the overload circuit breaker. From the overload circuit breaker, again the connection is given to the electricity meter. But for the electricity meter, both the live and the neutral wires, you can see the brown color live wire and the blue color neutral wire, both are given connected to the electricity meter. Now when we use an appliance, an electric device, we consume electric energy, and the amount of electric energy consumed by a household is measured in units. And each unit is equal to kilowatt hour. That is why this says kilowatt hour meter. So in 1 hour, if you consume 1 kilowatt, then that means you have consumed 1 unit of electric current, electricity consumption. So we will try to understand how that happens. To do that, students, I have this electric kettle here. Now this also has a switch and it is plugged in here to the socket. So now the main switch, that is the overload circuit breaker, is on, and here also all the switches are on. And like I told you all, everything, the levers are turned up. Isolator, the lever is up. The trip switch or the RCCB, the lever is up, and the MCB also, the levers are up. So everything is turned on. But here this switch is off. Now when I switch this on, now the electric kettle also has to be turned on. You can see now it is working. If you look at the indicator there, can you all see the indicator rotating? So that will rotate, and after a certain point where we have consumed certain amount of electric energy, you will see a reading here. Those are the units that we consume. Now if I turn on the lights also, the speed at which this rotates increases actually. So I'm going to switch off the light, students. Now you all can understand there is that black color line. Normally you can see here when it rotates there will be a black color line there. So every time that passes, one circle is completed. Like that, when a certain amount of electricity is consumed, you will see the meter reading here. So that is how they calculate the amount of electricity a household consumes. I am sure you all can understand that. That is the function of the electricity meter. Now I am going to switch this off. So you all can understand how the electricity meter works. Now when all the devices are switched off, you can see here the indicator has stopped moving. There is no rotation there. So that means there is no reading. Only when we use electric devices, there will be a change there. I am sure you all can understand that. Okay, students. So like I told you all, this is the consumer unit which contains the isolator, the trip switch and the distribution box with the miniature circuit breakers. So when we open the lid, you all know this is the isolator. Isolator contains the main switch with the main fuse. So here this part from this component, that is the isolator component, rest of the components belong to the consumer. So all these belong to the household people or the consumers. Here again the isolator switch has the lever. You all can see now it is in the on position. So manually also you can turn it off and you can turn it on. And there is a maximum of 30 ampere current that will be allowed to pass through the isolator. If there is higher current more than 30 amperes, then automatically the service fuse that is connected to the main switch turns off the household circuit. That means it will cut off the power supply to the whole household. So therefore, this acts as a high current fuse. If there is current more than 30 amperes, the current supply to the household will be cut off. And here, the isolator has the ability to cut off current to the live wire and the neutral wire. Here you can see in this connection, both the brown and the blue colored wires are connected to the isolator. So because of that, these type of switches are called dual pole switches, where there is connection to both the live wire and the neutral wire. Both wires are cut off. That is why we call it as the dual pole switch. So isolator can be operated manually, and in the case of current more than 30 amperes, it switches off the current supply, the power supply to the household. That is what you need to understand about isolators. Okay, students. So if we try to understand the function of a trip switch. Now when we connect a device to the circuit, now let's say we connect an electric kettle to the plug socket and it is working, and there is a casing, a plastic casing, and normally an earth wire is connected to that casing. If there is a current leakage, then of course current will flow through that, and that will be detected at the trip switch, and the trip switch will turn off. Now at this point you all can see the lever is up, so that means the switch is on. The trip switch is on. So there is power supply to the household. Now if I switch on this light, you can see, if I switch on this light, here you can see the bulb is lit. That means there is power supply. Now we have to make sure that the trip switch or the RCCB, residual current circuit breaker, is functioning properly. To do that, here you can see this small button that is known as the test button that is there in the trip switch. Now if I press that test button, the trip switch immediately turns off. The lever moves down and the power supply to the household circuit is disconnected. Now if I switch it off and then turn on the trip switch, again if I switch it on, it will work. Now again if we press the test button, it disconnects the power supply. That is how a trip switch or an RCCB, a residual current circuit breaker, functions in the household circuit. So both the overload circuit breaker and the residual current circuit breaker, that is the RCB or the trip switch, both of them cut off the power supply to the whole household. The full household circuit, the power supply is cut off. That is what you all have to understand here, students. So students, now we will look at the function of the miniature circuit breakers. Now all the switches are turned on. The levers are on. Overload circuit breaker on, meter is connected, isolator is on, and the trip switch is on. From that, connection is given to the distribution box where we have the miniature circuit breakers or MCB. Now here you can see two miniature circuit breakers. Again in these also, when the levers are up, the switch is on. So current will flow through that. When the lever is down like this, the switch is turned off and there will be no current flow. Now at this distribution box, different parts of the household is supplied with current. As I told you all before also, students, the household is divided into different parts and there are different MCBs for different parts of the household circuit. There is the lighting circuit and the plug circuit. You all know for the lighting circuit, only 6 ampere current is provided, whereas for the plug circuit, 13 ampere current, a larger current is provided to the plug circuit. And also you all have to remember, students, there is a certain number of devices that can be connected to each MCB, so that the current that flows to that part of the household is limited. So now what happens is, let's say the kitchen. If the lights are connected in the kitchen and if there is a problem in the circuit, this particular MCB, the fuse will turn off that part of the circuit. So the kitchen will not have electricity, but the rest of the house will have electricity. Now I will turn it on. I will switch this on, and if this turns off, you can see automatically the power is turned off. There is no electricity supply. So again, we can turn it on manually also. You turn it on again, you turn on the switch. If the MCB again switches off, that means there is a problem in one of the devices you are using in that part of your household. So that has to be rectified before using it again. So that is how MCBs function. This is the modern MCB what we use nowadays as part of the consumer unit. Here I have an MCB that was used in the earlier days. Now here you can see, when you look at the shape, the structure of it, it's similar to an overload circuit breaker. I showed you all that before. Here you can see there is a wire. Now can you all look at the thickness of this wire? It is a very thin wire. Why? Normally to the household overload circuit breaker, it's 40 amperes. But for a lighting circuit, it's only 6 amperes. For a plug circuit, it's maximum 13 amperes. So if there is a current more than that, this wire should melt and the circuit should be disconnected. That is why the wire is more thin here. So that is the miniature circuit breaker or MCB that is present in the distribution box. So this is again to protect electric devices, appliances being affected by excess current, high current. So that is the function of an MCB, which you all have to understand, students. Okay, students. So like I told you all, this is the consumer unit which contains the isolator, the trip switch and the distribution box with the miniature circuit breakers. So when we open the lid, you all know this is the isolator. Isolator contains the main switch with the main fuse. So here this part from this component, that is the isolator component, rest of the components belong to the consumer. So all these belong to the household people or the consumers. Here again the isolator switch has the lever. You all can see now it is in the on position. So manually also you can turn it off and you can turn it on. And there is a maximum of 30 ampere current that will be allowed to pass through the isolator. If there is higher current more than 30 amperes, then automatically the service fuse that is connected to the main switch turns off the household circuit. That means it will cut off the power supply to the whole household. So therefore, this acts as a high current fuse. If there is current more than 30 amperes, the current supply to the household will be cut off. And here, the isolator has the ability to cut off current to the live wire and the neutral wire. Here you can see in this connection, both the brown and the blue colored wires are connected to the isolator. So because of that, these type of switches are called dual pole switches, where there is connection to both the live wire and the neutral wire. Both wires are cut off. That is why we call it as the dual pole switch. So isolator can be operated manually, and in the case of current more than 30 amperes, it switches off the current supply, the power supply to the household. That is what you need to understand about isolators. Okay, students. So now we will have a look at the plugs. Plug tops or plugs that are normally connected to the plug sockets. So you all know in a household circuit we use different electrical equipment, electrical devices. So like the electric kettle, cooker, iron, like that. There are so many, even your laptops, when you charge your mobile phones, you all have to connect all those wires, the plugs, into the socket. So here I have a few of those. Now this is a plug socket. Here I am actually showing you all a multi-socket where you can put different pins, different sizes, different shapes, and different pins can be inserted into this particular socket. So we call this normally a multi-socket. But normally in the households, you all know there are different plug sockets which we saw in the model of the household circuit. So here I have some of these plugs. If you look at this first plug, here you can see there are two round pins. So this is known as a 2-pin plug, and the pins are round pins. Like this, you can even have square pins also. Now when we say 2 pins, there are only 2 wires connected to the 2 pins. One wire will be the live wire through which current flows into the plug, and the other one is going to be the neutral wire. There is no earth connection to a 2-pin plug. So normally the 2-pin plugs are not very safe, because if there is an electric leakage, then that excess current actually flows through the earth wire. But in the modern plugs, the nowadays ones, even the 2-pin plugs are somewhat safe because the electric equipment, the casing does not conduct electricity, insulating casing. So because of that, 2-pin plugs are also widely used now. Then here we have the 3-pin plugs. Now here also you can see these are all round pins and there are 3 pins in a triangle manner. Always the top pin, that is a broader pin. The diameter is large and that is usually connected to the earth wire. This large pin that is at the top is connected to the earth wire. Then you have the other 2 pins. This will be connected to the live wire and this will be connected to the neutral wire. That you can observe if you remove this plug top or plug. So normally students, there is a screw that is tightened here so that these two do not come off each other. But for now, to show you all how the wires are connected inside, I have removed this plug top. So like I told you all, you can take this off. I told you this is going to be the live wire. Now if you look at it this way. Now in this, your right hand side, that is this one, that is connected to the, you can see the brown color wire. So this is going to be the live wire. Here you can see this one, that is connected to the blue color wire, that is going to be the neutral wire, new pin connected to the neutral wire. And top is the green color wire, that is the earth wire connected to the top pin. So again, if you want to look at it, this is the earth pin. And here you can see it's connected to the green wire. And on this side, this is the live pin. Here it's connected to the brown wire. And this is the neutral pin. Here it is connected to the blue color wire. So you have to always look at the plug from this side. How the wires are connected. Your right side is the live wire, left side is the neutral wire, and always the top one is the earth wire. And always the top pin is large. Other 2 pins are of equal diameter. So like I told you all, here also the wire that is connected with the plug, you can see the colors. So here you can see the brown color wire, live wire, blue color wire, neutral wire, and the green color wire, the earth wire. All 3 wires are connected to the plug. And this will be plugged into the socket. Like this, you will be plugging it in. So that is going to be the way you plug in the plug to the plug socket. Then we have another 3-pin plug, but here you can see the pins are square pins. Here also you can see the top one is a bit larger. So that is going to be the earth pin. And here you have 2 other pins of the same size. And this will be the live one. Because you know when you turn it, this is going to be the live wire. And this is going to be the pin connected to the neutral wire. So you all have to remember that, students. So these are the plugs that we connect to the plug sockets so that you can use different electrical devices or electrical appliances.